Go. Right, so what we have here is a question that involves the application of using the solving a quadratic equation. So let's read the question carefully, as we should do. And I think I've chopped off part of the question, but it has. The top part of it there says, the diagram shows a cardboard photograph mounted on a piece of cardboard. And the first part says, write down an expression in terms of x for the area of the photograph. So the area of the photograph is this bit sort of in here. This is the photograph of the dog. A bit hard to see there with the highlighter that I use, but it's the photograph of the dog, and we want an expression for the area in terms of x. So there's a frame around the photograph, and that frame then has a width of x, and you can see that there. So all the way around it has a width of x. So you can probably guess at some stage we're going to work out what x is to find out, the width of the frame. Right. So to work out the photograph, I'll just zoom in on that a little bit, and we're going to look carefully and see what have I got. We know that this is 40, but that 40 has that x taken off it, and that x taken off it there. So if I want the area, the height of the photograph, then the area then is going to be 40 minus 2x. Okay, so that gives me what's left, which is this height there, right? So there's 40 centimeters minus x is 40 minus x. We have to do the same on the other side. So what I'm interested in is this length. And we've got the same deal that we had before, in that I have got x and x, which is subtracted from it. So that means I've also got 60 minus 2x. Okay, and remember, the area is always going to be one dimension times the other dimension. Okay, the height times the width. So if this is, I can put that up there, width times height. It doesn't really matter which is which, or base times height. In fact, sometimes we use base times height, don't we? Let's use base instead, seeing that we're kind of comfortable with that. And then if you really want to change things around, what did we decide the base was? 60. If we make that the base, which is now this measurement all the way along, there's our base, or actually not all the way along, is it? It's just this bit, the red line. And then our height is the red line on the right-hand side. So there's your base times your height, and we get that from that information. I better just fill that in again as well. So this is 40. It doesn't matter actually which way round you've got it, but I changed it just so that we've got the base times the height the same. So we do need to multiply that out. So if I do that, 60 times 40, 6 times 4 is 24, and then I add 2 zeros to make that right. 60 times 2x is 120x, so I've done that side of it. Then negative 2x times 40 is negative 80x, and then negative 2x times negative 2x is positive 4x squared. Okay, so there's my continuing with that expression. We'll simplify that a little bit. I like to have the 4x squared at the beginning, because that's what we're used to, and there's no effect on that at all. Then it's going to be minus 200x plus that amount there. So I've simplified it. Negative 200x minus 80x is 200x. Right, so we have done A. So the next part now is to find out, well, calculate x. What is x actually equal to? All right, now what we're told is that the area of the photograph is 800. So this A is now replaced with 800, and we go 4x squared minus 200x plus that amount there. Then what I'd like to do is to subtract 800 from both sides of the equation. So that remains the same as it was. But if I now subtract 800 from both sides, what I'm left with is 1600 over there. And what we have to do then, by the way, that's equal to 0, right? Because I've subtracted it, and I've just moved that equal to 0 over on the right-hand side. Okay, it doesn't matter. I could have left it here, gone 0 equals, makes no difference, right? But because we're used to seeing it on the right-hand side, we're just going to move it to the right-hand side. The other advantage of that is that when I come to my answer, I get x equals rather than something equals x. And again, it's just simply what we're used to seeing. All right, well, let's carry on. And I think it would be convenient to divide everything through by 4, okay? Because we can see here, when I come to factorize, I can do that. I can divide everything by 4. I could take a factor of 4 out. That would have the same effect. But because it's equal to 0, 0 divided by 4 is 0, so it doesn't change that. Therefore, I'm going to divide by 4 rather than taking a factor of 4 out. If you decide to take a factor of 4 out, still works, okay? There's no problem. So dividing everything through by 4, 200 divided by 4 is 50, and we get 400, and that's equal to 0. We now have to factorize that. There's a squared missing there. I'll put them back in. So once I now, I need to factorize that. And look, we can make a long list with 400, can't we? 1, 400, 2, 200, 4, 100, et cetera, to what works is 10 and 40. Okay. So if I put 10 and 40 in there, you can see that both of them need to be negative. All good? Yep. Because it works, doesn't it? So negative 10 times negative 40 is 400, and negative 10 minus 40 is 50. So, all right. So as before, when we've got a quadratic, we get 2 answers. We get the border width, it can be equal to 10, or it could be equal to 40. But it's a bit odd having 2 answers when, you know, we've got a picture like this. So we're going to go back and have a look at the picture and just consider our answers then 10 and 40. And we'll just make sure that those answers actually make sense. So if x is equal to 10, that would give me let's go nice, pink's nice. That would give me a width of 40 there and 20 there. So that works, right? If x is equal to 10, border, that works. So we're good with that. That could be it. Now let's consider the same thing. Perhaps I'll change color to, we'll go back to red again. So now if it was 40, if x is equal to 40, then 60 minus 40 is negative 20. And 40 minus 40 minus 40 is negative 40. Can you see there that doesn't work? Okay. So that answer, you know, having a picture of a dog that measures negative 40 by negative 40 centimeters doesn't work. So we're going to cross that one out. And I mean, it still comes up with a quadratic, but it's not a sensible answer. So when we get our answers, particularly with the quadratic, when we get 2 answers, we need to test to make sure that those answers are sensible. The only sensible answer is 10. Just recapping, what do we have to do? Well, we have to come up with an equation for the area of the photograph, which we did. And usually with this kind of practical problem, that's what we have to do. We have to somehow create an equation. Once we've got that equation, we set that, in this case, we set it equal to 800 because that's what we're told. But we may need to combine that with another equation, or in this case, we combine that with some extra information that we're given. We then solve it. Once we've solved it, we check our answers to make sure they make sense.